All right, kids, today we're hopping on the hottest trend from 3 months ago and playing Wordle. And by play, I mean cheat at. But don't worry, this is a judgment-free zone. You cheating pieces of shoot. So I want to create a little browser extension that will show a list of 5-letter words that you could guess given the current state of a Wordle puzzle. So if you get stuck, you can just show the list and get some help. Whatever I come up with, I'll put in a GitHub repo below. You could try this thing out for yourself. At its essence, what this application is about is reading the state of a Wordle puzzle with JavaScript and turning that information into a regular expression. Then, of course, we need a list of 5-letter words that we can filter based on that regex to give us our possible answers. Okay, let's start with our list of words. If you Google Wordle word list, you can find a GitHub repo that claims, at least, to have a list of words that are acceptable in Wordle. And you'll see there's almost 13,000 of these words. It's a pretty big list. Another place you could get what I believe is this exact same list is if you look at the JavaScript code that you actually download when you go to the Wordle page. So if we look at sources here, we'll find this main something or other.js. If you take this code, well, I'll just take it now actually, and paste it into a text editor, you will find, if you take a look through it, this area here, where there's a giant array of words. This, I believe, is the exact same list of words that you see on that GitHub repo. So I'm actually going to use the list on the GitHub repo because I think this array is broken into a couple of parts. And I hate doing work. So I'm going to take this list. We can copy it right from here. I'm going to use an online converter to take this list, hit convert, and right here we're going to have a JavaScript array with all these words in it. Copy that, and you can do something like this. And that's it. We now have our dictionary of 5-letter words. Now, to be clear, this list is not a list of answers. This is a list of permissible guesses, okay? You can look at some of these words like FYLES, right? If this was actually a Wordle answer, nerds would go to New York and tip over the Times building in protest. This is never going to be an answer. A lot of the words on this list, what the hell is a Phanos? A lot of words on this list are never going to be the answer. So again, this is a list of permissible guesses, but we're going to make do with this. Let's write a regular expression. If this is your first time, I'll be gentle, or will I? I like to use regex101.com because they have this handy reference, which I need because I suffer from regex amnesia. We write our expression here and we test it against a string that we put here. I'm just going to put some 5-letter word. And for my expression, I'm just going to put 5 periods. Beep, boop, bop, boop, beep. And basically this will match any 5 characters. And you'll see the string lights up blue because it matches the expression. So what if we had a Wordle puzzle like this? Well, we know there has to be an E on the end, so we can just put an E on the end. We have 4 periods and then an E. This will match any 5-letter word ending with an E. We know the first letter has to be an A. A dot 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 E will match any 5-letter word starting with an A and ending with an E. If I change this to a tone, it will match. If I change the last letter to something other than an E, I can't think of a word, I don't know, a Tony, it wouldn't match. Now, what about the yellow T? That means we can't have a T in the second position. We can express that this way. I'm going to put brackets, caret symbol, T, end brackets. You can look in the reference and see that whatever we put in the brackets is going to match with a single character only. So this part is only going to match our second character, and the caret symbol means accept or not. So I'm saying an A followed by something that isn't a T, anything, anything, E. So the string no longer matches because the second letter cannot be a T. Now it matches. If we had other yellow letters in the second position, we could just add them into the brackets. And it doesn't matter how many letters we add in the brackets, it's only going to match with a single character in the test string. We can add as many letters as we need into here. Now you're probably saying, I thought regex was hard, but this is super easy. Yeah, well, you're right. This is a little too easy for two reasons. One, we're lucky because we're only going to be checking against the strings that are in our dictionary. So we don't have any user input. We don't have to check for invalid characters. We don't have to check for word length. So we are getting away with a little something here. But also things are about to get a little more complicated, but not too much. I'm basically using the periods as placeholders here because I know we only have 5-letter words. And we can use this kind of expression for all the positional information in our puzzle. When we know where a letter has to be or where a letter can't be, we can very simply use an expression like this. But there's other kinds of information in a Wordle puzzle. For example, the gray letters are letters that can't be anywhere in the word. And the yellow letters tell us where the letter can't be, but they also tell us that that letter has to be somewhere in the word. And to express this information, I'm going to use positive and negative look-aheads. In the reference under group constructs, you can find these here. I'm going to be using a positive look-ahead whenever I need to assert that a letter must be in the word, and a negative look-ahead to assert that the letter can't be in the word. So let's look at an example that contains all the information in this puzzle. I'm going to paste in something here. The first part of this expression is saying what we had before, basically. It's saying we have to start with an E, then have something that's not a T, then anything, anything, E. This is all the positional information. Then we're going to follow that with a positive look-ahead. And if you're not familiar with regular expressions, you might want to look up under common tokens what the asterisk and plus symbol mean. But we're starting out by saying 0 or more of any character followed by 1 or more letter T's. So this entire positive look-ahead is basically saying there has to be a T somewhere in the word. And we're following that with a negative look-ahead that's basically saying there has to be an O. I'm sorry, it's saying there can't be an O anywhere in our word. And so we'd also need one more negative look-ahead to say we also can't have an N anywhere in our word. And this pretty much encapsulates all the information in this puzzle, right? The positional information and then positive look ahead to say has to have a T, can't have an O, can't have an N. So alone no longer matches because it has an N. So acute matches because it follows all of the criteria laid out here. So we should be able to represent any Wordle puzzle with this kind of format. First, we can have all of the sort of positional data, then some number of positive look-aheads for all the letters that have to be in the puzzle, and some number of negative look-aheads for all the letters that can't be in the puzzle. Now, by the way, you could sort of stop there. You could start cheating at Wordle immediately with just that. So let's say we had a puzzle that looked like this. You could just find all the gray letters, let's say SCO. I'm just going to take a sample, and we have a yellow, we have a Y in the second position. Let me just make that a Y, get rid of the E, and what does it have to have? It has to have a P. I'm going to just change this to a P. Now, of course, we also have to take our word list and paste it in here. And basically, if let's see, let's shrink this down, you would see match information on the side. As long as I have a multi-line selected, it will go through each of these in turn. So you can see that I have some matches here. And if I put in more information from this puzzle, I would get probably fewer matches or more accurate. But there's only 20 matches here, so this is actually pretty good. Yeah, so with nothing but what we've done so far with regular expressions, you could cheat your ass off. Okay, so we need to think about how we're going to turn the Wordle puzzle into some information that we can actually use. I'm going to open the developer tools here and actually just inspect the puzzle itself. And you can see that we have rows. We have a board with the entire game board in it. And then we have these game rows. And there are 6 of those representing the 6 guesses that you can make. So let's take a look at the second word. We have pylon here. In that we have individual game tiles. Each of those will tell you what the letter is, and there's an evaluation. Now this we're going to have to use, right? The evaluation is either going to be present for a yellow tile, basically, correct for a green tile, or absent for a gray tile. So we're going to need to go through the DOM with JavaScript, grab this information, and store it in some kind of way so that we can later use it to construct a regular expression. Now, I have decided to store it this way. There's nothing special about this. There's nothing clever about this. WordData.lettersR is just going to have, you know, if I know, if the last letter is a green E, I know it's an E, then this array would look like this, right? Letters are not is an array of arrays, because you could have more than one letter that you know a specific position can't be. So what we looked at before is that the second position can't be a T or an L. That would look like this. And must exclude is where I'm going to put the gray letters, right? The letters that we know can't be in the final answer. So letters are not is going to be used basically twice in the construction of the regex. One to do the positional data in the regex, and then again, I'm probably going to have to take this array of arrays and flatten it and potentially remove duplicates, and so that I can just use these letters in our positive look-aheads to make sure that they're somewhere in the word. On the Wordle page, we need to talk about how we can access the parts of the DOM that we need access to. So you might say, well, let's grab this div with an ID of board. Okay, and you'll see if we do a normal document.querySelector for the ID of board, we're getting nothing. The problem is that we have these shadow root elements. I believe these are actually called page fragments. What we could do before the shadow roots start, we have a game app element. So let's grab that real quick. Okay, so we are able to get that. If we do dot shadow root, we now get the document fragment that's in this shadow root. And from here, we can get the parts that we want. So if we wanted to access the ID of game, we could just do a dot query selector after the shadow root. And using that kind of technique, we can navigate the DOM so that we can extract the information that we need. In order to evaluate the board, you could write something like this. So I'm initializing some variables here. I'm going to go do a for each on each row. So these are the 6 rows, basically the 6 guesses that you're allowed to make in Wordle. In each row, there is an attribute, or there may be an attribute called letters. So here, let's go to the rows. Right here, game row. Sorry, that's not it. Oh yeah, a game row has a letters attribute if there's a guess in that row. And of course, if there's not a guess in that row, we don't need to evaluate it because there's no information. So if there is a letters attribute, then we're going to evaluate that row. We're going to collect all the tiles, which is to say all the individual letters. And we're going to loop over those letters and look at the attribute called evaluation. So if we grab a tile, they look like this. The evaluation is either present, correct, or absent. If it's absent, that means it's a gray letter, basically. We're going to stick it in our word data object in the must exclude array. If it is present, that means it's a yellow letter. We're going to push it into the letters are not array of arrays, into the appropriate one of those. And if the evaluation is correct, that basically means it's a green tile. That letter is already correct and it's in the right position. Then we push it into the letters are array in the appropriate index. Once we have all the data from the puzzle stored in some kind of way, we are going to need another algorithm to pull that data out and turn it into a string that looks like a regular expression, something like this, so that we can use that to filter our list. If you've followed me this far, I think you should be able to follow the code on GitHub if you're interested. By the way, it's a real pile of trash. I didn't refactor a single line, just wrote it and sent it right out the door. But I want to talk about some of the design decisions that I made as I was writing it. So first of all, I thought that what I would be doing is evaluating the board every time the user made a guess. I decided later that that's not very clever, because most of the time, most people will be making guesses without wanting to see the word list. It's only really for in case of emergencies where you really need a little bit of help. So what I decided to do was have the list in a sidebar that would auto hide. And only when you choose to open it will it then do the evaluation. And here's another issue that caused me to change my thinking. I would test this thing, and when I opened it after a couple of guesses, I'd realize that the list it was showing me, sometimes it would only be one word and it would just show me the word, which is just giving me the answer, right? I don't want to cheat that much, right? I want to be able to have a little help without just, here's the answer. So if the list of words is very short, I don't really want to see the list, because a lot of times that just basically gives you the answer too easily. So I decided that what I really wanted was to decide on a threshold. And if the list of words is above that threshold, go ahead and show me the list, because you're not really giving me the answer if there's 30 words left. But if the quantity of words remaining is below that threshold, then don't show me the list. What I would rather see is links to remaining letters that I can click on. And so that way, if the list is short, instead of handing you the list, it will allow you to see hints. So let's see this in action. I've got my Wordle helper extension running here. I've made 2 guesses. If I decide I want some help and I open the sidebar, this is the formatting that I want, right? If there are fewer than some number of words, and in the code that I wrote, it's hint threshold. So you can change this number, no problem. If there are the hint threshold number of words or fewer, instead of showing me the list, it will tell me how many words are remaining, and it will give me links to the individual tiles. So there's nothing here for letter 2 because we already know that one, right? So if I click letter 1, it says N 100%. So because there's only one word remaining, these are all going to be 100%. But if there were, let's say, 10 words remaining, 5 of them started with an N and 5 of them started with an L, then it would say N 50%, L 50%. So because there's only one word remaining, this is just going to give me the individual letters. But this is way better than giving me the list, or just showing me the word, right? Right now there's only one word. I don't want the word. I want help when I need it, right? I don't just want to be handed the answer. So this allows you to say, okay, well, what's letter 5? It's an H. And I could maximally cheat and see that the answer is nymph. And there you go. So now that pretty much does what I wanted it to do. The styling is gross. I definitely didn't try to make it pretty, but it does work. And I am going to leave it right there. I didn't intend to do a line-by-line sort of code walkthrough. I just wanted to touch on some of the important points. I think anybody who was able to follow this can figure out the rest by themselves, or just look at the GitHub repo. So I'm going to leave it there, and see you next time. Bye.